Okay, so here's H-20. The table below gives selected values for the differentiable. Differentiable means that you can take its derivative. Okay, so for the differentiable and decreasing function f and its derivative. If f inverse is the inverse of function f, it's kind of redundant, what is the value of f inverse prime of 4? Okay, now let me say a couple things, guys. Okay, so when they say a decreasing function, this just implies that f inverse exists, I guess. That f inverse is a function. All right. Okay, so let me just explain that real quick because this might be sort of distracting, a decreasing function, but they're just, okay. So just let me say this. So if you've got a function with this table of values, okay, 1, 5, and 8 for inputs, these are the corresponding outputs. This is a function. Every x has exactly one y. Okay, every x has exactly one y. That's the definition of a function. But the inverse of this would be like, you know, the domain and the range, the x and the y's, they switch. So now the y's, these y values are the domain. Now, this inverse is not a function because the x value 3 corresponds to two outputs, okay, 1 and 8. So when they say a decreasing function, that is just implying that even if you switch the domain and range, you would still have a function to deal with. And just another thing, so I just graphed, this is kind of dark, sorry, but I took these points and I graphed them, and you could see, that you end up with something that is not just decreasing. It's decreasing and then increasing. And because of that, if you pass a horizontal line through, that horizontal line is going to hit 2 points, which means that, there will be y values that have the same x value. No, that there will be x values that have the same y values. So then when you switch it around, that will mean that you have y values that have the same x values. I'm probably confusing you, I'm so sorry. But just this decreasing part, my point is that, I mean, you can kind of ignore it, but it is relevant, I guess, to the setup. But they won't often even say that. Okay, sorry if that was long-winded. All right, so blah, blah, blah. So that's what we want to find. All right, so guys, let me just go through the steps now. This inverse notation is really messy, especially when you put it especially when you put a prime outside of it. So what I recommend to students, if they have a situation like this, is that you let G equal F inverse. Okay, so we want G prime of 4. All right, so this is actually G prime of 4. Now, if you're going to do this on a test, you need to tell your reader that you're letting G equal F inverse. Okay, otherwise they won't know what you did. Okay, so now we want G prime of 4. We have values of F and F prime. If you're dealing with inverse functions and you're asked to find a derivative, you want to use the inverse derivative formula, okay, which is from the last phase. So let me find G prime of X first. So G prime of X is going to equal 1 over its inverse prime of the original G. So G prime of 4, 1 over F prime of G of 4. Now you look at this table of values, we need to find G of 4 first. But there's no G values in this table. But since you've got these X values and these F values, you can make a table for G. Okay, it's going to be the inverse. It's going to be the inverse, so you're just going to switch these two columns. So F G of X is going to look like this. These are going to be the new inputs. The old outputs are the new inputs. And then negative 4, 4, 6, 7. Okay. So now you can see right here, G of 4 is 6. Okay, so this right here is telling us that G of 4 is 6. So G prime of 4 equals 1 over F prime of 6. And now we can use our original table. So 6, and there's the F prime column. So F, if you plug in 6, F prime is going to be negative 5. So G prime of 4 is 1 over negative 5. Okay, just like that.